Welcome to episode 258 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm okay, Rob. How are you doing?
Doing okay. Any news or anything you have to share?
Not particularly. I'm planning to do some more streaming on my YouTube channel today and tomorrow, but this won't air until tomorrow, and it's too late for people to tell anyhow. But you have to be subscribed to me on YouTube if you want to know about these last-minute streams. So I guess I can just make that as a plug, I guess.
Oh, that's a good plug. What exactly are you doing on the stream today?
I'm going to be recording some hacking on the game engine stuff that I started about 7 months ago at the beginning of the year because it hasn't been moving as quickly as I would like it to on the channel. So I just figured I'm just going to stream, I don't know, like maybe 10 to 15 hours of stuff over the next couple of days while I just hack on it and see if anyone cares.
Cool. Very cool. Okay, well, at the top of the episode, I like to read a piece of feedback. Speaking of YouTube, we got this YouTube comment from an episode we did several months ago.
Yeah.
Someone's catching up on it, I guess. This was the Commodore 64 and Tilt 5 AR episode with Jerry Ellsworth. And Riley commented, you should team up and make new baby Commodore 64s and new games for them, which I think is aimed at you, Jason.
Perhaps. That episode is so much fun. And what he's referring to, just in case our listeners don't remember, is on air, Jerry said that she had something like 100,000 dies left from the Commodore 64.
Just sitting in her closet.
Yeah. From this project, the Mammoth Games Commodore 64 joystick that I still have sitting on my desk right now, which is a system on a chip Commodore 64 implementation. It would be awesome for those things to see the light of day. Yeah.
Yeah, definitely. Have you been tracking that Kickstarter? Has that started shipping out yet, the Tilt 5 stuff?
I remember a few months ago seeing notifications that it was starting to ship, but I hadn't checked again after that, since I wasn't one of the I didn't buy one.
No, I didn't either. It was a little expensive, but I'm looking forward to seeing how well it does. Yeah.
I know several of our listeners did because we got tweets and stuff, people talking about having bought it.
Right. Okay. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Josh Filstrup. Josh is a senior engineer working in the visual effects industry with a focus on building creative tech that scales. Currently, he works in the studio engineering group at Netflix. Previously, he has worked at Disney Animation and Pixar. His computing interests are in programming languages and high-performance computing, and lately exploring the history and specification of old game console hardware. Josh, welcome to the show.
Hi, thanks so much for having me.
I feel like you put that last sentence in there just so I would ask you about it.
It's funny. I made the connection just as you were talking about Commodore now. I hadn't thought about it, but it's really that during the inside times, as I'm calling them, I've found many new hobbies, and one of them is exploring obscure hardware.
Okay, what's the most obscure hardware that you've been researching?
So I've been spending a lot of time thinking about the Sega Dreamcast lately, like probably far too much time thinking about the Sega Dreamcast. The one rabbit hole I went down was, so they had this processor called the Super H processor.
Mm-hmm.
And it was pretty big back in the day in a lot of embedded devices, apparently. And it turns out that there's this group in the open source community called like the J-Core group that did a clean room implementation of like that instruction set on like a new open source chip. Because apparently the patents for the second Super H processor, the SH2, just expired. So they're able to do like these clean room implementations. So it's this crazy, crazy rabbit hole you can go down. And there's just a lot of like interesting, obscure hardware. The Dreamcast in particular is interesting to me just because it did so much that was ahead of its time. Like one example is it had a broadband adapter. And mind you, this is like 4 years before the PlayStation 2 really did it with Final Fantasy 11.
Mm-hmm.
And it just, the Dreamcast was really, really weird. It did a bunch of advanced stuff.
It was one of the first of the 32-bit era, right? Is that right?
The Dreamcast came out before PlayStation 2. So it was 9/9/1999 in America. I think it was about a year before or so in Japan.
Okay.
But it had power that rivaled kind of like the PlayStation 2 GameCube era.
Awesome. So are you then now implementing emulators, or did you buy an FPGA kit so you can like have your, like, what are you doing?
So I started with restoration. So I had a really old couple of Dreamcasts that my mom mailed to me because I was like, I don't have anything to do. Can you mail me those broken Dreamcasts? So I've been repairing those. And one of them had like a chip that essentially unlocked the BIOS to play games from any region. And so I was like, oh, this is like really cool. If I can make it work again, this would be really fun to play with. So first it was like learning about like proper like plastic restoration and all these like hardware tricks. And then soldering new fans in and all these kind of parts that typically die. One part that's like super common to die in there, they had this thing called a GD-ROM inside the Dreamcast. And the GD-ROM was like a CD-ROM, but it had a gigabyte disk. So it standard for gigabyte disk.
Okay.
But it was like this, proprietary format. And so like when these things die, there's kind of no saving them. Like, it's like because only Dreamcast had GD-ROMs, like nothing else had it. Whereas like a CD-ROM drive, you can kind of find them all over the place. Maybe you could kind of salvage it.
Right.
So essentially you end up Frankensteining parts out of GD-ROMs. Other things that fail on them are super common, like power splice and things like that. So you just end up replacing all the capacitors and you're good to go. So it was a lot of hardware stuff like that. Now on the software side, I've moved on to doing emulator implementation, but I'm starting small and just emulating the CPU itself. So I'm just working on a Super H emulator. And then it's like, if that goes well, maybe a Dreamcast emulator.
That's awesome. So, wait, but does the Dreamcast work yet?
Oh yeah, both of them work. So I have two, and they both work.
They both work.
One is completely OEM, and the other is much more standard new parts. Like people have developed new custom power supplies for them, new emulator chips that replace the GD-ROM, and people have even gone so far. If you look up a thing called the DC Digital by these like two really brilliant hackers. It's an HDMI FPGA that solders directly to the motherboard and gives you true 1080p output. Like, it's insane the level of, like, things people have developed for these old consoles.
So one of them's original and the other one has all those things installed?
Yeah. One of them's original and one's the one I actually want to hook up to my TV.
Did you have to recap all of them?
So you don't, like, the motherboard was pretty good on the one that's hooked up to the TV. You don't have to. But, like, people sell full kits, so I'm planning to at some point soon, but I haven't gotten around to it yet.
I'm just thinking about your setup personally, because I invested in a decent soldering iron not that long ago, because a decent soldering iron is not that expensive, but a decent desoldering gun with a vacuum pump in it, I just can't convince myself to spend a couple $100 or whatever on one of those, because I would only use it like twice. I know I wouldn't,
Yeah, I actually just got a nicer soldering iron myself as I started getting into this, because I had like a $12 one that was like no temperature control.
Right.
It didn't even have a stand to put it, so I was like precariously setting it on the table and hoping to not burn myself. And so like I at least got like a nice one with a stand now, but I also can't go that far because it's like I feel like I'll use it still like maybe 10 times a year.
Yeah, maybe, yeah. Yeah, okay. Something we never talk about on this show, really.
Yeah,
hardware
we haven't
hacking.
gotten into hardware for a while.
Yeah.
Okay. Well, Josh, we got a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about the work you're doing at Netflix, okay?
Cool.
All right. So this first one is an update to wxWidgets 3.1.4, which is the first update in, I think, 9 months. And we did have an episode with wxWidgets, but that was the episode where we had some pretty poor audio quality. So I feel like we should maybe do a follow-up again and talk to someone from wxWidgets soon, maybe.
Still on my to-do list, yeah.
Yeah. But a couple of notable things in this one are they're able to compile with C++20 now, which is great. Some CMake build improvements. Anything else you wanted to call out here, Jason?
There's this one line item right here. wxOS Export now supports the latest macOS 11 on ARM hardware. Now, as far as I know, No one has access to a Mac OS 11 on ARM hardware, so I'm really curious exactly how they tested that and what that means.
Those
So
lightweight MacBooks, like MacBook Air, that's not on ARM?
No, that's
no,
not ARM
they
yet.
they actually did send out dev kits though.
Okay.
So there are select developers. They essentially sent out. It looks like it's a Mac Mini that has like, I think like an A12X chip in it, which is like the iPad Pro chip or something.
Okay.
And so that's what people are using to test development. So when they did the announcement, they had like this sign up sheet where you had to like sign an NDA and put in a deposit and do all these things. But they've facilitated some amount of testing for that.
Okay.
Oh.
So yeah, all right, that's cool. So yeah, that's awesome. Somehow, somewhere that got tested, presumably.
Yeah.
Right. Okay. Next thing is GCC 10.2 release, which is a bug fix release. And they have a whole list on Bugzilla of all the different bugs that got fixed, a little over 90 of them. Any interesting ones you saw on here, Jason, that you wanted to call out?
No, but the Reddit discussion is hilarious. At least the top-rated comments are. The 9 stages of debugging your C++ code basically is the Reddit discussion there. I won't spoil it for anyone.
Yeah, it's definitely worth reading through some of the comments here, though.
Yeah.
One thing I noticed was and I haven't read these kind of feature lists in a long time, but it looks like 10.2 rounds out the concept support in GCC. That's what I'm seeing when I look at the feature list. It just says like 10.2. There's a little parenthetical comment, so it's maybe not fully complete, but it looks like it's mostly there, which is really cool. I mean, I remember hearing about concepts for a long time, so it's cool to see it kind of finally coming together. I know it's been like a controversial feature, so not everyone's happy with where it landed, but I think it's great that it's at least landing and people will be able to get some benefit.
Yeah, there's at least 5 or 6 issues in here that are directly related to fixing concept support. I've noticed in my own playing around that GCC's concept seems to be one tiny step ahead of Klang's concepts right now, so it's really cool, yeah, to see them all coming in.
Yeah, and in general, just quick shout out to the GCC developers. I think they don't get as much kind of praise as kind of the LLVM, which is the more visible kind of compiler community these days, but they do a lot of tireless, wonderful work. And in the entirety of my VFX industry time, GCC has been the backbone for all the C compilation we do. So great job to all of them.
That's awesome. It's probably also worth pointing out too, since we're talking about C++ 20 support, if you look at the compiler support for C++ 20 features, GCC is ahead of everyone else right now.
It's honestly incredible on both sides. It's always incredible to me how fast they get stuff out. I remember when like C++ 14 was getting ratified and like Clang was like, oh yeah, we already implemented all that. And it's like, wait, what? When?
Yeah, that's a funny one because I think Clang implemented all of that stuff, then submitted the proposals to the standard for a lot of C++ 14 related things.
Yeah, it makes sense too. C++ 14 was, if I remember correctly, a much smaller release.
Yeah.
Okay, and then the last thing we have is that C++ on C. The videos are already becoming available on YouTube. I'm not sure if it's all of them, but it looks like they have about 50 videos, including 12 that are lightning talks. So I'm not sure if that's everything. I don't remember how many tracks they had, but it's great to see them already available on YouTube for those that did not attend the virtual conference and want to watch the content.
Yeah, if you look at the list of videos that are online, Phil, I assuming Phil's doing a lot of this work, but I don't know. The conference seems to be posting about 4 a day, 5 a day, depending on the day. So they should be done pretty quick, I would think.
Yeah. I did start watching one of these videos. I need to finish it. But Cybrand did one where they made a compiler for, try not to curse on the show, but for
You can say
Brain
BF.
Yeah, BF, which looked very interesting, and it was impressive to do that in a conference talk.
Yeah, I also have 2 or 3 of them open now and like partially completed. I started watching Matt Godbold's talk on correct API construction last night, but then I got tired. Not because of the talk. It was just very late. Yeah, there looks like a lot of fantastic talks, and it's really cool that everyone's able to attend these things now.
Yeah.
Yeah, I feel like a little bit of mixed feelings about this. Clearly, the conferences are much more accessible now, and at the same time, it's just a completely different experience, right?
Yeah, I think I definitely miss being able to go and just meet people and say hi. That I remember the last C++ conference I was at in person was C++ Now, which was 2 years ago in Aspen, I think. And like, yeah, that one's particularly like intimate. So you just get to have a lot of these like fantastic conversations with people in the community. So I do miss that part.
Yeah.
Okay, well, Josh, could we start off by you telling us a little bit about what exactly you do at Netflix? And I know in your bio you say you work on the studio engineering group. So that's the actual like production of some of Netflix's original shows, I'm guessing, and not, the back end of Netflix hosting and streaming all the content.
Yeah, I don't work on kind of like, keeping the website alive or anything. Luckily, I am not entrusted with such great responsibilities. So if your streams ever go down, it's not my fault. But they actually have like the team that works on that stuff is brilliant. And like anytime they show us stuff, it kind of blows my mind. So yeah, I work in the studio engineering group, which is very similar to what I did at Pixar and Disney, right? And so what I work on in particular is underlying libraries that take care of kind of data pipeline transport issues, right? So one example is artists tend to use many what are called DCCs or digital content creation applications. So you can think of these as like Maya or Photoshop or Houdini, right? And so kind of shuffling the data from one place to another, there's a lot of libraries involved in that. And so I tend to work on the optimization of like export and import utilities across those different tools. And then within the tools, a lot of times there's interesting data transformations you want to do, and there's typically underlying low-level libraries that take care of that and make sure it's performant. The reason I call out underlying libraries is typically the way these APIs are surfaced is in Python. So there's developers that typically work in Python, and they write a lot of scripts for kind of automating different tasks for artists, but that Python calls into C and C++. So those are kind of the two core languages for animation and visual effects is Python and C++.
I feel like, if you don't mind, we need to take one step back maybe for our listeners who aren't familiar, and forgive me if you did say this, but you're referring to the fact that Netflix is a movie studio at this point, right?
I mean, there is a part of Netflix that produces original content, right?
But that's who you're working with, right? You're working with the artist on the original content stuff.
Yeah.
This isn't pipelines of processing compressed video or something.
No. There are very cool teams of very smart people who I actually talked to pretty recently who do work on like compressing video and all that stuff and like new algorithms for compressing video, which is kind of mind-blowing. But yeah, we're in the content creation business. I'm not as close kind of to the production side as I would be at Disney or Pixar, which are just kind of, smaller operations. So you're just kind of all in one building. But the same kind of concept, building tools that enable creatives to create.
That's a weird statement. I'm sorry that you just said that Disney and Pixar are smaller than Netflix when it comes to this kind of thing.
Yeah, Disney or Pixar. When I say Disney, I mean Disney Animation. So it's like just the animation studio. And smaller in the sense that they're all kind of co-located into one place, right? Whereas Netflix is much more of kind of at least within our org is distributed across a few places. So we're all distributed now. So what does anything mean anymore?
Yeah. I almost said something, but I decided not to.
Before we get into some of the more technical stuff, can you tell us some of the original content kind of projects that you've been involved with?
Sure. So I can't say anything for Netflix. I can't talk about any of those titles. But there are some movies that have come out that I could talk about. So for Pixar, I was credited on Coco, which is my favorite movie to work on there, and Cars 3, which if you haven't seen Cars 3, nobody gives it a chance. It's actually like awesome, and people should watch Cars 3.
It is really good, actually. Yeah, I watched it on an airplane, which I know is not the full movie watching experience, but it was still really good.
But like Cars 3 is like legit underrated. And then when I was at Disney Animation, I worked on Frozen 2 and Wreck-It Ralph 2, and those were both like fantastic projects. So those are kind of like my 4 public credits. I've worked on a few other films at Pixar and at Disney. They were just I had only been there for a little bit of time, so you're usually credited once you've been there for a little while.
So if I had watched the 10,000 names at the end of the movie scrolling past, yours was in that.
Yeah, like Frozen 2. I got prime real estate in Frozen 2 on the credits as well. Like I was in the middle, which is like it was a real come up. I was excited.
That's awesome.
Very cool.
How many times have you seen Frozen 2, Rob?
Just the once. I think my daughter's probably watched it 2 or 3 times though. Yeah.
I was gonna say since you
Frozen 1, that got seen a lot in this house though.
Yeah, when I was like younger and I had to like babysit my cousins, one of them was obsessed with Finding Nemo. Mm-hmm. I think I watched Finding Nemo like 57 times over a year. It was like that was like legit all they wanted to do. They were just like they'd show up to the house and they'd be like, "All right, put on Finding Nemo." I'm like, "All right, yes, you guys should know how it ends by now, but all right."
That's awesome. Yeah. Oh, so you mentioned this in your bio that you started with a programming language, or you have programming language background. How did you make this move from programming languages into all this VFX stuff?
Yeah, that's a good question. So I'll just give kind of a little quick history that kind of probably explains it, and if not, we can just follow up with other questions. So after I was finishing my undergraduate degree, I had been working at a spectrum analysis company. So they build like testing equipment for cell phone towers, like embedded devices, all that kind of stuff.
That sounds like fun.
Yeah, it was really interesting. Surprisingly, they were still able to use like pretty advanced libraries on that stuff. Like we were using Qt 5 at the time, which was like pretty cutting edge. This was like back in like 2012.
Wow.
But I was like, I wanted to do something kind of a little more, I guess I could say just like kind of obscure and do some more kind of exploration about like what I was excited about in computing at the time. So I started doing some graduate work in programming languages. And at the time, this was in like DSLs and Haskell and like type theory and kind of all those things. I don't know if you've heard of automated theorem provers.
It's come up on the channel a couple of times, people talking about being able to prove the correctness of software.
Yeah, so I was really interested in kind of very, I'd say, out there stuff in terms of languages, like, and only out there in the concept of like how much kind of mainstream programmers would really be able to use it day to day. Mm-hmm. And then kind of after about a year of that, I was pretty homesick and I was missing kind of some of the practicality I'd been feeling at my job. And I got an offer from Pixar, and Pixar's in the Bay Area, and I was originally from the Bay Area, so it was a pretty natural fit for me to kind of go home and start working there. And so that's all that really happened in the transition there is I was homesick, and I had a large background in working with C++. Like that's kind of what my original like interest in programming all started in C++. Like everybody else, I wanted to program video games, right? Like that's like a lot of C++ programmers, like how'd you get started? It's like I wanted to make games. Yeah. And so that was like that's how I fit at Pixar because obviously everything's in kind of C++ and Python for that world. So I had the right skill set, and then once I started working there, I just fell in love with the task because visual effects is one of those really cool industries where you're getting to work on like these really neat properties, but also like you have these interesting performance problems. Like the performance constraints are like really significant in visual effects, much like games, but in a different way. And so that was super compelling, and I just kind of never looked back.
Awesome.
Very cool. Has your programming language background been useful in the visual effects industry?
I think it's a double-edged sword, right?
Okay.
Like, so like when you've spent enough time in like programming languages, like any other thing, it's like, I know what's out there. And so like sometimes I get frustrated, particularly when I'm having to use Python, I get a little frustrated just because some of the tooling I find lacking for kind of ensuring software correctness. But on the whole, I think it's been great. And the way it kind of manifests for me is just really, really heavy leaning on using great tools, right? Like in C++ land, we have this fantastic suite of tools, like all the sanitizers that LLVM and GCC put out, right? And those things are just incredible. And I think really it's just been leaning into using all the tools at our disposal to make C++ easier to write more efficiently and more correctly.
I'm on board with that.
Yeah.
Do you then find yourself when you do need to use Python, like trying to use the like gradually typed Python or some of these other things to try to give you another layer of correctness?
So I would like to do that. The visual effects industry, you had some buddies of mine, Carl and David Adler, on a couple weeks ago, and they mentioned the visual effects platform.
Right.
We are just now moving on to Python 3 in the visual effects platform.
You mean away from the thing that was deprecated and ended of life like 10 years ago, you're just now getting rid of?
You know, I'm not going to confirm or deny the deprecation status of Python 2, but yeah, so we're just now moving there, right? And so like a lot of the great tooling that has been made available in Python that would have made me complain less is almost all tied to Python 3.
Right.
Like there's like 2 or 3 different like really impressive looking type checkers. Like there's MyPy, there's Pyre, and I think there's one more that I'm forgetting for Python, but they're all like Python 3.5 minimum, Python 3.4 minimum. So you kind of hit a wall. You're like, oh, cool, a new Python tool. And then inevitably it would always be like, you can't use it.
So, but now you are moving into a world where you might be able to start using some of these things.
Yeah. And at Netflix, like it's much more clean slate. Like it's a pretty new org, right? So we've been able to kind of start in a better place with the tooling on that stuff, right? But it's like for Disney and Pixar, you know, they have code bases that are 20 years old by now. I remember when I first got to Pixar, there was a math library written by like a programmer that had been there a long time, and it was literally older than me. And I was just like, okay, all right, let's.
What are some of the libraries you spent the most time working on throughout your career in VFX?
Yeah. So the biggest project I worked on, I think, that I was working on even once I was at Disney, but it started when I was at Pixar, is a project called USD, which stands for Universal Scene Description. So this
Not
is
the US dollar.
Not the US dollar, which is an unfortunate acronym clashing, but what are you going to do?
Right.
So USD is many things, but you can think of it kind of from kind of 10,000 foot perspective as a file format and underlying set of libraries to manipulate that file format that acts as an interchange between those DCC applications I mentioned, right? So I could spit something out of Maya and pull it into Houdini, or I can spit something out of, Katana and pull it into Maya. But like the interesting capability that USD gives you is it has this notion of composition. So the idea is that assets are going to be getting created from many, many places. And a lot of times we want to be able to do these groupings and granular non-destructive updates. So an example would be I have 3 or 4 models. So these are geometry files coming out as .usd files coming out of modelers. And I want to go ahead and pull them into a scene, and then I want to translate them into different places. So I can use these notions of composition to say I want to pull in this, this, and this model, and then I want to apply a transform on it. And this transform I'm applying on it is a non-destructive edit. And what USD does is it knows how to compose those based on kind of the grammar that it defines for composition ordering. And it gives you, like if you're a renderer or whatever, here's kind of your final resultant scene. So it's saying like, I know how to do all this fast composition logic, and it allows you to have these very granular files where it's like, this is my geometry file, this is like my shading file, this is my sets file. And what this enables is many artists can work on the same shot at the same time. And so it really enables kind of parallelism across departments, which is really, really cool.
This is a project you're continuing to work on. You've worked on for a long time also?
I haven't worked on it much in the last year. I've been pretty busy since I started at Netflix.
Okay.
Like we definitely use USD, like or we're definitely interested in USD. But it was something I definitely worked on from like 2015 to 2019 pretty heavily.
I feel like we get a surprising number. Well, perhaps it's just the nature of how we learn about people for this show, but a surprising number of people who have been paid or have professionally worked on open source projects throughout their career.
Yeah, it's actually like super fortunate, and I'm like really, really grateful. Like not a lot of people get to work on kind of like open source as a job. And so like that was like such a unique opportunity. And just seeing what it takes to really put a C++ library out there in a way that works across all these platforms reliably, like just like, you know, the build complications you deal with is like kind of immense. And then you get into things like platform differentiation. Like it's unfortunate that a lot of these libraries kind of duplicate the work of having kind of this platform layer that defines all these different things. Like it'd be great if more of that could merge into the standard, but it's really cool to kind of see how the sausage gets made there.
So does this project also have to support that standard that the film industry uses?
Yeah, so
I can't remember what it's called.
The VFX Platform, yeah. So it supports it. USD, last time I checked, compiles on Windows, Mac, Linux, like kind of your standard things. The standard operating system for visual effects is usually like Red Hat or CentOS. So that's kind of like the standard platform they use, but it does work on Mac and on Linux. And it's C++ 14 last time I checked. And then it should just essentially work with all those libraries. It interops with a few things like Boost and OpenVDB, so it has pretty good compatibility across those. But I know there has been interesting challenges with Boost if like the Boost version is new enough and you're on Windows and things like that, which isn't that surprising. Whenever I've had to build Boost on Windows, it's been a challenge. Or really, when I build most C++ software on Windows, it's usually a challenge. But I will say, I've been doing a lot of development on Windows lately in my free time, and the VC package folks are doing a fantastic job.
That's good.
Things are so much better than they used to be. Like it's great.
I can't remember if we've had someone specifically we have had someone from the VC package team on.
I think so. It's been a while, but we have, yeah.
Billy O'Neill was on pretty recently, right?
Oh, that's right.
Yeah.
He just switched over to VC package, I think, from working on kind of more the compiler team or the standard library team.
Yeah.
He was on loan, but I think a recent tweet from him said that it's now his full-time move.
Oh, okay.
Yeah. I think it's honestly like a super valuable thing for the C++ community to have this. I kind of hope VC package gets more and more traction and we can all just kind of agree on a package manager. I think like outside of language features, it's one of the biggest problems in C++. It's just like every time I go to build something, it's some bespoke setup from someone.
Yeah.
Yeah, I mean, I've settled on Conan myself, and that's, you know, I'm glad, though, that we have, at the very least, a few options that seem to have a standard set of packages available, right? Like we can pretty much assume Boost and libformat and whatever is going to be available in every direction, and things are definitely getting better.
Libformat, correct me if I'm wrong, this is just a curiosity. Is that the one that's getting merged into the standard?
It is, but specifically only the form. Sounds a little silly to say.
Subset of it.
It's a subset. It's only the formatting subset. So libformat also has its own like printf and its own IO stuff.
Oh.
So if you want to use libformat with IO streams or whatever, then you would have to do like format and then insert that format into cout basically. So it kind of ends up as this weird hodgepodge, but it's easy to write like helper routines that make it look pretty.
Okay. Yeah, that makes sense. It's actually one correction I might make. I haven't checked, but I'm actually not sure if I'm gonna check right now if USD is actually technically C++11. It's so for a long time, everywhere I've worked, like when we've been kind of forced into C++11 compliance, we get C++14 by just having a header that adds like the few things we really care about out of it, like make unique and stuff like that, because it was always easy enough to write make unique, and that was always like the one big glaring omission for me. That was the one thing I missed.
Yeah, I strongly feel like C++14 is a bug fix to C++11, and you should just skip 11 if you can.
Yeah. And namely, a big thing that we noticed back when I was at Pixar is 14, the compiler support, especially in GCC, was just a lot better in terms of compliance, but also performance. Mm-hmm. Namely, like I remember pretty early on, the std regex was like implemented, but like the performance was really, really rough. So I remember someone moved a thing from boost over to std regex, and like we have these like nightly performance tests kind of like everyone else, and they just tanked. And we just reverted back to boost regex, and it was fine.
I'm not surprised at all. That might still be the case.
It got better. I'll give the GCC developers credit. It got a lot better. But I mean, if boost is kind of your performance benchmark, you're not in a great place.
Well, as long as they're still talking about USD, and I get that you haven't worked on it in the last year, but you did spend a lot of time on it. And you said it's this universal screen description. I just have this like mental image of like when I'm using OpenOffice and I say save this document as a Word format, it's like, oh, this is going to work, but you're going to be missing some features, right? Like this always happens when we're transferring between file formats. And you're talking about how like all the different 3D software uses this thing. Do you have the same thing happen when you go to export from the native format to this, that it's like, hold on, there's a few things that I can't do?
This is actually like a really great question. So a lot of times what happens, I'll just give an example. When I was at Disney, a lot of times we had a lot of specific stuff going on in Maya that was pretty specific kind of to our plugins or like just custom in-house software we were writing. And what USD kind of allows is like, there's what I like to call this kind of escape hatch of like metadata. Metadata can be these untyped dictionaries that you can just kind of jam into a file.
Okay.
So essentially, any time that we were like, oh, we don't really know how to encode this like properly in the scene in a way that transports, which didn't happen too often, but when we did, we were like, oh, we could just put it in metadata. And we would create a little wrapper API for accessing that metadata, but that would essentially get us where we needed to go in terms of encoding any kind of application-specific things. So there was always kind of a way around that.
It sounds like that then becomes a really hard design decision when you go, okay, is this important enough that we need to add a new feature to USD versus jamming it into the escape hatch?
Yeah.
Right.
Luckily for me, there were much smarter, more experienced people who kind of make those decisions at the global level. I was very much like the young like pup in the USD group of like very experienced C++ developers when I first started there. Namely, Sebastian Gracia, everyone calls him Spiff. He's been at Pixar forever, and he's kind of like one of the lead designers of USD, and he's just super thoughtful about like what really needs to be included and what doesn't, in the same kind of way that the standards committee is like very thoughtful about the implications of changes to kind of the C++ standard. So luckily there's really good kind of arbiters working on that.
Awesome.
Okay. Well, if you haven't worked on USD too much in the past year at Netflix, what have you been working on?
So a lot of NDA things, but essentially, like I've been working on in the same space as USD, communication tools between applications, right? So it's like, how do we effectively communicate? But you can imagine in a more distributed world, so like things at kind of modern computing companies, right, is a lot more distributed across like cloud services, right? So then it's like essentially like, how do you move kind of this kind of work into the cloud? And this is a challenge I think that a lot of companies will be facing, just because more and more kind of this scalable computing is becoming a question that places with on-premises computing have to at least think about, right? And so it's, how do you take this infrastructure and make it work in kind of this new environment that has like these elastic computing clusters that are all accessed over the internet? So I think it's building services that are scalable, but not just scalable with respect to compute, but also scalable with respect to kind of like network latency and things like that, and being like fault and failure tolerant with respect to networks. So I think that's been a really interesting challenge for me, because coming from those previous environments, we didn't really have to care about the network at all, right? Like in a typical visual effects house, like you're all on like a shared file system. So like, I guess you could say it's like there's a network in terms of NFS, but not like a traditional network as you would think of it.
Mm-hmm. So I saw this press release here from Netflix tech blog that they are working on a community, visual effects community with the VFX platform, but this whole thing it's very light on details. Not being someone in the industry, I'm just curious if this is something you're involved in with your special effects work at Netflix, or anything that you can talk about.
Yeah, so NetFX is adjacent to my group.
Okay.
So I know people in the NetFX group, but I don't directly work on it, so I can't really comment on their work. But definitely a lot of the core technology we're developing will be shared with the NetFX group. And they're a bit more kind of customer in the sense of kind of artists and shows and things like that, whereas we're a bit more insulated, kind of we build like the layer below them of kind of core technology.
Okay. So for people interested, it sounds like this is kind of a watch this space and see what comes up over the next few months kind of thing. Yeah,
definitely watch this space. I think actually doubling back to your kind of previous question, there's one thing I thought would possibly be interesting to delve into,
Sure.
that you two might have thoughts on, which is kind of the performance profile in VFX and like what performance kind of means in visual effects.
Okay, sure.
So I think like this is something C++ does like incredibly well, right? C++ allows you to target performance targets in a very straightforward way. I think Chandler Carruth said this a long time ago, and I've always loved this quote. He said like C++ doesn't give you performance. It gives you like the ability to understand your performance. Right? Or like it gives you kind of like this like direct mapping. I may be like muffing the quote, but that was the gist of it if I remember correctly. And it was always interesting like when I hopped into VFX, because to give you context, a visual effects artist works on a workstation that has about 200 gigs of memory, dual socket, anywhere from like 30 to 60 cores, right? And
Nice.
then like big quadro graphics cards, right? So those are like kind of like the professional line of NVIDIA cards. I don't know much about GPUs, so I can't say much about those. But the performance profile of like those individual machines is really interesting, because you have to run very efficiently on those, but you also have to run a lot of these same processes on like a traditional render farm, right? Which is like just thousands and thousands, like Carl was mentioning, thousands of cores running in like a data center. And a lot of times you need to kind of very much tune for both of those scenarios. I remember this is when I found out about performance and kind of got my butt kicked really early on at Pixar. So I was given a task that's like, essentially you have all these kind of per frame geometry files coming out of this FX application, which does like volume simulations and things like that. And it kind of, for every second or every like frame in the simulation, it's spitting out like a per frame file, which is like a bunch of geometry. And you need to run something that can process every single one of these files in parallel and kind of generate what's called like an aggregate topology, which is like, this is all the geometry you might see, because this manifest allows people to view it a lot more efficiently if they know everything they're going to be looking for. And so I was like, okay, cool. I know C++. I know what I'm doing. You know, I was like pretty fresh out of college, didn't know what I was doing, but I was like, I got this. And so I go to write it, and it's like I do it on my little test, and I'm obviously using these small dummy test files because, of course, I was. And it runs fast. And I'm like, this is great. Submit it. And then, like, it was like a week later, an artist is like, hey, my simulation export is taking like 45 minutes. And I was like, oh no, like, what's happening? And I go look at it, and for like a 5 or 10 second like export of like frame time, it was about 60 gigabytes of data. And so I had vastly underestimated the cost of doing this, and quickly I ratcheted up my parallel programming skills, because I was, of course, also doing this in a single-threaded pass, because I was like, it'll be fast enough. Who needs multi-threading here? And of course, I was wrong. So that was like my quick introduction to kind of like the scale of data working in visual effects, but also the need to kind of like actually exploit these many, many core machines. And for that, in visual effects, kind of the tool that we go to, which may be going away given the current standards trend, is Intel's TBB. And that's actually been like one of my favorite tools. Is Intel's TBB is just like, especially for like basic like parallel for and parallel reduce and things like that. Like they just expose like a really simple way of doing it. Like you just pass a lambda, it does the thing, and it's for like basic use cases, it just kind of works. So that's been great. But I don't know if the new parallel standards track, I haven't followed it at all, so you guys can let me know, but I assume it's going to be replacing at least like parallel for and kind of the basic pieces there.
Yeah, I mean, parallel for each it's in C++ 17, right?
Okay.
But I just try to not, sound optimistic, I guess I should say. Visual Studio has support for it. GCC has support for it. Clang Standard Library still does not. So it's one of these things that's been super lagging. Like after the compilers said that we have full C++ 17 support, it's like a big asterisk that says, I mean, if you don't look at the standard library. So, but by the time that the visual effects standardization tools that you guys use catch up to C++ 17, you will have it.
Hey man, in 2021, we are going to be right there on C++ 17 on the bleeding edge of technology.
Well, hopefully your compilers that you need to rely on will have it by then.
Yeah,
so.
It's always funny to me because, visual effects goes at a bit of a slower cadence in terms of adopting technology. But like when I first worked at an embedded company, which it was like very traditional, like, brown building, cubicles, like, kind of your standard fare. And like they were so bleeding edge with the C++ they used. Like we were on like C++ 11 in like 2011 or 2012. Like,
right.
And it was like not even fully implemented across the board. And then like we were on C++ 14 as soon as like the Clang piece dropped. And this is like running it on like embedded ARM devices. And so it's just funny. I think like a lot of times the size of your team determines like how nimble you can be on those things. And we were a pretty small group, so we were just able to move those code bases over pretty easily.
Yeah, right. And now you're an industry-wide standard that you have to deal with.
Yeah, and Carl and David touched on this, and honestly, David knows kind of the problem a bit better than I do, but a lot of it is this ABI issue, right? Where it's like you have to have, like a lot of times these libraries will get released, just as SO files or DLLs or whatever that need to interop inside these packages. And it's like, if there's any kind of like ABI breakage across those, you're just kind of hosed. So then it's like everyone has to move in lockstep with like the same compiler, the same basic settings and all those kinds of things, which definitely makes it tough. Like what ends up happening, right, is like most studios end up building kind of like a sandbox environment, because like you'll have multiple shows, right? And a lot of times shows will lock to kind of different versions of things. And so like you'll essentially have like, you may have a different version of Boost building in like different shows, but you essentially have to like rebuild the world for that version.
Right.
So, I mean, I think and it can get pretty rough in terms of like compile time and stuff. Cause again, like you're kind of rebuilding the world. I remember like the longest compile time I've ever seen was like 3 hours, give or take. And this was on one of those like big 30, 40 core machines. So this is like, yeah, it can get pretty bad. But you know, what are you going to do when you're locked into a vendor? You just don't have much say over that.
Right.
I've got this question that's kind of been forming, and maybe I'm going out on a limb a little bit here, but you have your programming languages background, and you've talked about how you want to rely on the tools, make everything as like, as good as possible, right? Like correct as possible. And you're talking about these like USD and what am I trying to say? Like a scene transformation, pipelining tools, right? So I'm imagining, okay, that a considerable portion of your work is like, this has to be exact, this has to be perfect. When we translate these scenes, when we do geometry transformations, whatever, this is all perfect. And then it reaches a point, right, when it actually goes to be rendered and displayed by whoever, that accuracy is not the important thing anymore. It needs to look good and it needs to render quickly. And I'm just wondering, like, do you have to deal with, like, does that border actually exist? Or am I just making it up? Do you have to deal with it, and does it drive you crazy?
Yeah, I mean, there's definitely, to your initial question or part of it, like, there's definitely this, it has to look good, it has to look right. But right. At kind of like the stage of the pipeline I've typically existed in, you can think of it as a lossless transformation on most of the stuff I work on.
When so everything you work on has to be exact.
Yeah, when you get to the stage of like, I mean, exact, like we work with a lot of floating point data, so nobody's going to be exact. but and I actually have a quick funny bug story after this for that. But on like the rendering side, to your point, there is an amount of noise that kind of David and Carl got into a couple weeks ago, where they have these like really cool tools called like, I think they're called like perceptual diff and things like that, which is like, it can do an image diff, but it has like this tolerance level. So it's like, does this actually perceive to be the same image, even if like, 2 pixels are different? So it has a kind of intelligent way of understanding. This is basically the same image. There's no substantive like transformation that's like really like making this look improper in some way. The funny bug that I ran into, so this is, there's this library called OpenEXR.
Okay.
Yeah, and so OpenEXR has their own half floating point type, and it's like a 16-bit float.
16-bit, yeah. There's some talk about standardizing 16-bit floats, actually.
Yeah, I think a lot of people in games have maybe talked about it for like the space saving and stuff like that.
Right.
But so like they have a constructor, and the constructor takes a float, right? And obviously it halves the precision, and I was running into this case where like all my data was coming out wrong. And what I found out was the constructor was non-explicit, but it like took me, so there was a function that accepted a half, but I didn't realize that was the function getting invoked because half had an implicit constructor from float. Right. I thought I saw a function that took float. And this was like, I was like, you've seen that like picture from It's Always Sunny where the guy looks like crazy and he's like pointing at all the drawings on the wall. I was at that point of like looking at my code and I was like, what is happening? Like, am I crazy? Like maybe I'm actually crazy and like I should just like leave. Because and like when I finally figured it out, that was one of my few like C++ table flip moments. I was just like, make your constructors explicit. Why do you hate me? And so, yeah, OpenEXR will always hold like a special place in my heart for that moment.
That's awesome. And that's great too, because I mean, if it's a built-in conversion, you can at least ask the compiler to warn on it. But since it was a user-provided conversion, I can't think of any way that you could have even gotten a warning that you were doing this.
That if I was going to ask the standards committee for something, that does remind me. If you're listening, standards committee, I want strong type defs, please. Strong strong type defs, like look at new type in Rust or Haskell. That's what I want. If you want me to write the proposal, I'll do it. I need it.
I talked to someone about that. Was it on air? I don't remember now.
I don't remember.
There have been strong type def proposals, I believe, for as long as C++ has been a standard. But they always get abandoned because no one can agree on what exactly it would mean. That's my understanding.
I think you're correct because I've looked around before and I've seen them. It can be emulated pretty easily. I remember someone showed me this at I think I was actually at a Haskell conference, and then someone was just look at this cool C library trick I did. So I don't know how it kind of came about, but essentially it's if you have a struct with a single element in it, the compiler is smart enough to treat it as if you were just holding that single element, right? So it knows how to kind of elide anything there. So, and I think all you have to do is have an explicit constructor on it, and then you kind of get what you want in terms of those conversion issues.
I think the problem and why it's never been standardized is which operations does it have, and how do you enable or disable said operations? Yeah,
I think it's, this actually touches on a really valuable point I was hoping to make, which is that C++ solves a really hard problem, and I think the PL community doesn't give it enough credit for what it does. It's super fun for them to dunk on C++, right? I get it. C++ is super complicated. We all know that. But they have the really hard problem of maintaining backwards compatibility, right? So anytime they make these decisions in the standards committee, they're I can't break this code from 1992. That code needs to keep working. And so every decision they make has these deep implications. And then it's when you don't have a module system or kind of any way to properly separate these compilation units, they're just left in a really difficult place. The fact that they got lambdas into the language is kind of incredible, right? So I just hats off to the committee. I don't agree with everything that happens, and the language frustrates me sometimes, but they're solving a really hard problem, and so they don't get enough credit for that. There's things that could definitely be more optimal. I wish C++ had real proper algebraic data types, but again, they're having to work in a way that doesn't break old stuff.
Yeah, so to that point, you said your industry is just now moving to Python 3, and that's because Python 3 to Python 2 was a break.
Yeah.
If C++ had a break, forget it. How long would it take you to cross that break?
I think that's what's always been interesting to me is when people talk about let's just fork the language. It's if you want to fork, just write Rust. Rust is a good clean room implementation. It's the reason we're not forking is because we want all that old stuff to keep working.
Right. Yeah.
And C++, to be clear, has gotten a lot better in the last 5 or 10 years, however long it's been now, since C++ OX came out. It's gotten much, much better. But yeah, it's if you have a clean room thing and you have maybe big security concerns or anything like that, Rust is a great option for that. But a lot of us have these big code bases we need to keep working with or interop with, and C++ gives us a great option to do that. So I think, a fork is just not a legitimate option in my mind. No. I think Herb has mentioned, and this is a long time ago, so I don't know how he feels about it now, but Herb has mentioned the notion of flags to say I'm in kind of new C++ mode. They can compile things maybe with some of the C backwards compatibility gotchas out of there.
Right.
And maybe that's a way forward, but I think again you probably need to get to modules before you can really have proper kind of compilation modes. That way they can all kind of separately compile to this intermediate representation.
Sorry.
No, go ahead.
I kind of personally feel by the time you've enabled a considerable portion of your compiler's warnings and run it through Clang Tidy or something similar and are willing to actually listen to those warnings, that we've pretty much done that. We've effectively forked the language without breaking backward compatibility. Only use these things that don't generate warnings now.
Yeah. I agree. And there's issues of spurious warnings making too much noise. That always happens in these kind of systems, and it can be a little frustrating. What I've come to find in projects though is once I've set up a proper kind of ignore list, or to like turn off warnings that don't really matter to me. This happens in Python too with Pylon and all these kind of tools that have frivolous warnings I don't really care about. But once you've kind of set up your infrastructure, it hasn't really been a problem for me, and it's mostly caught issues that I was glad that it caught. Like, sure, sometimes you're like, oh, it's nothing, leave me alone. And I think a lot of that comes down to the ergonomics of properly setting up a development environment where you can develop without being bothered, and then on submission to CI, actually do all those checks is usually how I set it up, where it's like, let me make my mistakes and write this kind of crappy first pass code, and then you can yell at me later. But before it actually gets like merged in.
Right. Okay, Josh, it's been great talking to you today. Where can people find you online?
Cool. So I'm Superfunk with a C on Twitter if people want to see me talk about programming and mostly only programming. And I'm also Superfunk on GitHub. So my website is just superfunk.github.io because I'm too cheap to pay for a domain. But I don't blog very often, so Twitter is the best place to get a hold of me if you want to talk to me.
Okay. It's been great having you on today.
Awesome. Yeah, thank you guys so much for having me. I really appreciate it.
Thanks.